Embark on an unprecedented journey across the cosmos with the SpaceX Starship, where the red sands of Mars are not just a destination, but the beginning of humanity's greatest adventure. Witness the dawn of a new era where space travel transcends the bounds of science fiction, becoming a tangible reality. Join us as we defy the limits of possibility and take the first steps toward a future among the stars. Are you ready to be part of the mission that will change the course of human history? In the annals of human history, the SpaceX Starship stands as a beacon of our interstellar aspirations, a testament to what human ingenuity can achieve when it dares to look beyond the confines of Earth. Conceived by SpaceX, the aerospace manufacturer and space transport services company founded by Elon Musk, the Starship is not merely a spacecraft. It is the culmination of decades of scientific breakthroughs, engineering feats, and an unyielding desire to expand the boundaries of human exploration. The SpaceX Starship, with its sleek stainless steel exterior, represents the pinnacle of modern rocket design. It is engineered to be a fully reusable transport system capable of carrying up to 100 passengers to destinations including the Moon, Mars, and potentially beyond. Its design and capabilities mark a significant departure from the rockets of the past, which were often used once and then discarded, making space travel prohibitively expensive and environmentally unsustainable. As we delve into the technical marvels of the Starship, we uncover a vehicle designed for the future. It features a powerful propulsion system, advanced heat shield technology for re-entry, and a versatile architecture that supports both crewed and uncrewed missions. The Starship is poised to revolutionize space travel, reducing costs and increasing accessibility to outer space for humans and cargo alike. The vision for interplanetary travel has long captivated the human imagination. It whispers to us of a future where Earth is not the final frontier but the starting point for a broader exploration of the cosmos. SpaceX's Starship is the embodiment of this vision, crafted not just for orbital jaunts, but for the audacious goal of making life multi-planetary. Elon Musk's vision for the Starship is driven by a profound belief in the necessity of establishing human settlements beyond Earth to ensure the survival of humanity. Mars, with its relatively hospitable environment and proximity to Earth, emerges as the primary target for colonization. The Starship is designed to be at the forefront of this monumental endeavor, offering a viable path for humans to live and work on another planet. This vision encompasses not just the technological advancements needed to reach Mars, but also the development of sustainable habitats, life support systems, and a self-sufficient economy that can thrive independently of Earth. It's a vision that challenges us to reimagine our place in the universe, urging us to take the next leap in our evolutionary journey. The importance of Mars colonization transcends the mere expansion of human territory. It touches on the very survival of our species and the continuation of our quest for knowledge. Mars presents an unparalleled opportunity to answer some of our most profound questions about the origins of life, the nature of the universe, and our place within it. Colonizing Mars would serve as a hedge against existential threats that face humanity on Earth, such as asteroid impacts, supervolcano eruptions, or the more insidious dangers of our own making, like nuclear war or climate change. By establishing a self-sustaining colony on Mars, we can ensure the long-term survival of human civilization, safeguarding the collective knowledge and culture accumulated over millennia. Moreover, the journey to Mars and the establishment of a colony there would catalyze advancements in technology, science, and engineering. The challenges of living on Mars would drive innovation in energy production, resource utilization, and life support systems, with wide-ranging applications on Earth and beyond. The endeavor would also foster international cooperation, as the magnitude of the task transcends individual nations, requiring a concerted effort from the global community. In essence, Mars colonization represents the next giant leap for humankind, offering us the chance to extend our reach, safeguard our existence, and embark on the most extraordinary adventure of our time. It beckons us with the promise of discovery and the potential for a new chapter in the human story, one not confined to the cradle of Earth, but spread across the stars. At the heart of SpaceX's ambitions lies the Starship, an engineering marvel poised to redefine the boundaries of space travel. The Starship's design is a symphony of form and function, merging aesthetics with cutting-edge technology to create a spacecraft unlike any before it. Measuring approximately 50 meters in length and 9 meters in diameter, its imposing structure is built to withstand the rigors of both deep space and planetary atmospheres. Constructed primarily from stainless steel, the Starship's material choice is both practical and strategic. This alloy provides high strength, tolerance to extreme temperatures, and resistance to the corrosive effects of space travel, all while facilitating the spacecraft's signature gleam. The design also incorporates large windows, designed not just for the breathtaking views they will offer passengers, but also to ensure psychological well-being during long-duration missions. The spacecraft is segmented into several key areas, including the payload bay, crew quarters, and the propulsion section. The payload bay is designed for versatility, capable of accommodating satellites, interplanetary probes, and cargo destined for the Moon, Mars, or beyond. The crew quarters are a study in efficiency and comfort, designed to support a crew of up to 100 individuals on missions lasting months or even years. Propelling the Starship on its journey is the Raptor engine, a masterpiece of propulsion technology. The Raptor is a full-flow staged combustion engine, burning liquid methane and liquid oxygen, methalox, as propellants, a choice that supports the vision of refueling on Mars using locally sourced materials. The Starship and its Super Heavy booster, the massive first stage required to escape Earth's gravity, are powered by a combined total of up to 42 Raptor engines. This configuration provides the thrust necessary to reach orbit and beyond, with the capability to generate millions of pounds of thrust. The Raptor's design emphasizes efficiency, power, and reliability, offering a higher specific impulse, a measure of engine efficiency, than previous engines, which is critical for interplanetary travel. Central to the Starship's mission is its capacity to carry humans and cargo across the solar system. The spacecraft is designed to transport up to 100 passengers on long-duration flights, offering an unprecedented level of access to space. This capacity makes it an ideal vehicle for Mars colonization efforts, providing a viable means of transporting large numbers of people and the equipment necessary to establish a sustainable presence on another planet. The cargo version of the Starship is designed with a similar focus on versatility and capacity. It can carry a wide range of payloads, from satellites and space telescopes to components for space stations and habitats. The payload bay's design allows for the deployment of both traditional satellites and larger modular structures essential for building the infrastructure of a spacefaring civilization. A cornerstone of the Starship's design is its reusability, a feature that represents a paradigm shift in space travel. Both the Starship and the Super Heavy booster are designed to be fully reusable, capable of returning to Earth, landing vertically, and being rapidly prepared for subsequent missions. This reusability drastically reduces the cost of access to space, making ambitious missions like Mars colonization feasible. The Starship's heat shield is a critical component of its reusability, designed to protect the spacecraft during the high-speed re-entry into Earth's atmosphere. Constructed from heat-resistant materials, the shield enables the Starship to withstand the intense heat generated during re-entry, ensuring the spacecraft's integrity and the safety of its crew and cargo. Moreover, the Starship's design includes innovative features like aerodynamic control surfaces for precise landings, rapid refueling capabilities, and the ability to perform in-orbit refueling. These features not only enhance the Starship's reusability, but also extend its operational range, making it a truly interplanetary vehicle. The journey of the SpaceX Starship to the cosmos begins with its liftoff from Earth, a feat made possible by the Super Heavy booster, the most powerful rocket booster ever created. Towering at an approximate height of 70 meters and designed to be the foundation upon which the Starship ascends, the Super Heavy is the epitome of human engineering and ingenuity. Equipped with up to 33 Raptor engines, the Super Heavy booster generates the unparalleled thrust required to propel the Starship out of Earth's gravitational clutches. This colossal engine array is capable of producing more than 16 million pounds of thrust, an awe-inspiring demonstration of power that embodies humanity's relentless pursuit of exploration. The design of the Super Heavy booster, like the Starship, emphasizes reusability. Following its role in the initial phase of the journey, the booster is engineered to return to Earth, landing vertically on specially designed platforms. This revolutionary approach not only underscores SpaceX's commitment to sustainability, but also marks a significant reduction in the cost of space travel, making the dream of Mars colonization increasingly attainable. The launch process of the SpaceX Starship, assisted by the Super Heavy booster, is a meticulously orchestrated sequence of events that begins long before the engines ignite. Positioned on the launch pad, the Starship sits atop its powerful companion, ready to embark on its historic journey. Upon ignition, the Raptor engines of the Super Heavy booster roar to life, their combined force breaking the shackles of Earth's gravity. The ascent is a breathtaking spectacle, a testament to the power of human ambition and technological prowess. As the spacecraft climbs, it undergoes a series of controlled stages, including the separation of the Super Heavy booster, which then makes its descent back to Earth for recovery and reuse. The Starship, now in the upper atmosphere, ignites its own Raptor engines to complete its journey to orbit. This crucial phase of the launch process demonstrates the Starship's capabilities as a fully integrated spacecraft, capable of navigating the final stretch to space independently of its booster. The fueling and preparation of the Starship and Super Heavy booster are critical components of the pre-launch sequence, requiring precision and attention to detail. This process involves loading the vehicles with liquid methane and liquid oxygen, the propellants that power the Raptor engines. The choice of these propellants is strategic, not only for their efficiency and power, but also for the possibility of sourcing them from Mars in the future, furthering the sustainability of interplanetary travel. Safety protocols are paramount during this phase, with stringent checks in place to ensure the integrity of the spacecraft, the booster, and the launch infrastructure. The preparation also includes a series of pre-flight tests, simulations, and checkouts to verify the system's readiness for the mission ahead. The coordination of these procedures underscores the complexity and precision required for space travel. Each step is carefully planned and executed, from the initial fueling to the final pre-launch checks, ensuring the safety of the crew, the spacecraft, and the mission's success. The odyssey from Earth to Mars demands more than just an advanced spacecraft. It requires a strategy to extend its reach across the solar void. A critical component of this strategy is the Starship's in-orbit refueling capabilities, an innovative solution that underscores the ingenuity behind SpaceX's interplanetary vision. This process involves launching additional Starship tankers to orbit, where they rendezvous with the crewed Starship to transfer fuel. This not only replenishes the Starship's reserves, but also equips it with the necessary propellant for the long journey to Mars and potentially back to Earth. This method of in-orbit refueling is pivotal for several reasons. Firstly, it allows the Starship to use its fuel more efficiently during liftoff, conserving enough propellant for the crucial maneuvers beyond Earth's gravitational pull. Secondly, it showcases the potential for establishing a sustainable infrastructure in space, laying the groundwork for future exploration and even commerce. The ability to refuel in orbit effectively turns space into a hub of activity, not just a void to be crossed. The trajectory to Mars is a delicate balance of physics, timing, and resource management. The journey from Earth to Mars is not a straight shot, but a carefully calculated transfer orbit, typically a Hohmann transfer, which is the most fuel-efficient path between two orbits. The timing of the launch is critical, with windows opening approximately every 26 months when Earth and Mars align favorably, a period known as the Mars transfer window. The transit time to Mars, while dependent on the specific trajectory and propulsion system, typically ranges from 6 to 9 months with current technology. The Starship's design and its in-orbit refueling capabilities, however, hold the promise of reducing this time, making the journey not only feasible, but also more bearable for its crew. This reduced transit time is crucial for minimizing the crew's exposure to cosmic radiation and the psychological challenges of long-duration spaceflight. Sustaining human life for the duration of the journey to Mars is no small feat. The Starship's life support systems are designed to be robust, capable of maintaining a stable environment for its crew. These systems manage everything from air quality, water recycling, and waste management to providing food and medical care. The closed-loop life support system is engineered to maximize efficiency, recycling air and water to minimize resupply needs. Temperature control is another critical aspect, as the spacecraft must maintain a habitable environment despite the extreme temperatures of space. The Starship is equipped with thermal regulation systems that protect its occupants from the cold of space and the heat generated by onboard systems and human bodies. Moreover, the psychological well-being of the crew is a paramount concern. The Starship includes features designed to mitigate the effects of isolation and confinement, such as exercise equipment, communal areas, and possibly even areas for growing plants, not just for food, but to provide a psychological boost. As the SpaceX Starship approaches Mars, its design tailored for both the vacuum of space and atmospheric re-entry becomes crucial. The Martian atmosphere, composed primarily of carbon dioxide and only 1% as dense as Earth's at the surface, presents unique challenges for spacecraft entry, descent, and landing, EDL. The Starship's aerodynamic design is a masterclass in engineering, enabling it to navigate this thin atmosphere effectively. The spacecraft's shape and structure are optimized for stability and control during the descent through Mars' atmosphere. Its design includes aerodynamic surfaces, such as flaps and fins, that allow for precise control of its angle and speed during entry. These features are pivotal in managing the spacecraft's descent trajectory, ensuring it can handle the atmospheric drag and turbulence encountered as it decelerates. Entering Mars's atmosphere at high velocity subjects the Starship to extreme heat due to atmospheric friction. To protect the spacecraft and its inhabitants, the Starship is equipped with an advanced heat shield, designed to withstand the searing temperatures of Martian atmospheric entry. This shield is comprised of heat-resistant materials that ablate or wear away during entry, absorbing and dissipating the intense heat generated. The entry procedures are meticulously planned, with the spacecraft's orientation and speed carefully managed to optimize the effectiveness of the heat shield and ensure the safety of the mission. The Starship's entry into the Martian atmosphere is a critical phase, requiring precise control and timing to navigate the thin air and bring the spacecraft to its designated landing site. Landing on Mars poses significant challenges, given the planet's varied terrain and the need for precise touchdown to ensure the safety of the crew and the integrity of the spacecraft. The Starship leverages advanced precision landing technology to navigate these challenges, capable of pinpoint accuracy in selecting a landing site. This technology includes a suite of sensors and navigational aids that provide real-time data on the spacecraft's position, velocity, and the terrain below. Coupled with sophisticated onboard computers and algorithms, the Starship can adjust its descent in real time, maneuvering to avoid hazards and aligning itself with the landing site. The use of retro-propulsive landing techniques, where the spacecraft's engines are used to slow its descent and enable a controlled touchdown, is a key feature of the Starship's landing strategy. This approach has been successfully demonstrated by SpaceX with its Falcon rockets and is further refined for the Starship's Mars missions. Upon the successful touchdown of the SpaceX Starship on the Martian surface, a critical first task is the unloading of cargo and equipment. This phase is meticulously orchestrated to ensure the safe and efficient transfer of supplies, habitats, scientific instruments, and rovers from the spacecraft to the Martian surface. The cargo bay of the Starship, designed for easy access and unloading in the low-gravity environment of Mars, plays a pivotal role in this operation. Robotic systems and possibly the crew themselves participate in the unloading process, employing a combination of automated machinery and manual oversight. The equipment unloaded includes the essentials for initial survival, infrastructure building, and scientific exploration. This might encompass prefabricated habitat modules, life support systems, solar panels for energy generation, and equipment for in-situ resource utilization, ISRU, which is crucial for producing water, oxygen, and even fuel from Martian resources. The establishment of habitats and infrastructure on Mars represents a monumental step toward a sustainable human presence on the red planet. The habitats, initially transported as compact, deployable modules, are designed to provide protection against Mars's harsh environment, including its extreme temperatures, radiation, and dust storms. The construction of these habitats involves expanding the prefabricated modules into larger living spaces, connecting them to form a cohesive base. The infrastructure also includes life support systems that recycle air and water, energy generation systems primarily based on solar power, and ISRU plants. These facilities are critical for reducing dependence on Earth for supplies, making the Mars base increasingly self-sufficient. The layout and construction of the Martian base consider the need for both efficiency and the well-being of its inhabitants. Spaces are designed to support scientific work, social interaction, and personal privacy, acknowledging the psychological challenges of living on a distant planet. With the establishment of a base on Mars, the Starship's crew turns its attention to the primary mission objectives: exploration and research. Mars offers a rich tapestry of geological features, climate history, and potential signs of past life, making it a treasure trove for scientists. The Starship serves as a mobile science laboratory, equipped with advanced instruments for analyzing soil samples, atmospheric data, and geological formations. Rovers and drones deployed from the Starship extend the reach of human explorers, allowing them to investigate areas of interest that are too distant or hazardous to access on foot. The scientific goals on Mars include understanding the planet's history and evolution, searching for signs of past life, and assessing its resources for future colonization efforts. Research conducted on Mars also provides invaluable insights into Earth's past, present, and future, offering perspectives on planetary science, climate change, and the potential for life elsewhere in the universe. Upon the successful touchdown of the SpaceX Starship on the Martian surface, the mission transitions to its next critical phase, unloading the cargo and equipment essential for establishing a human presence on Mars. This process involves deploying a variety of tools, machinery, and materials needed to build the first Martian habitats, life support systems, and research facilities. The spacecraft's design includes cargo bays and deployable ramps or cranes designed specifically for this purpose, allowing for the efficient transfer of heavy and bulky items to the Martian surface. The unloading process is carefully planned and executed, with priorities set for immediate necessities such as habitat modules, power generation equipment, and life support systems. This ensures that the foundational elements of the Martian base are established quickly, providing a safe and sustainable environment for the crew. The establishment of habitats and infrastructure on Mars represents a monumental endeavor, akin to laying the cornerstone of a new civilization. The habitats are designed to be durable, capable of withstanding Mars's harsh environment, including extreme temperatures, dust storms, and radiation. These structures not only serve as living quarters but also as research labs and communal spaces, designed to support the physical and psychological well-being of the inhabitants. Infrastructure development includes the setup of power generation systems, such as solar panels or nuclear reactors, water extraction and purification systems, and communication networks to stay connected with Earth. The initial habitats may be prefabricated units brought from Earth, but the long-term vision includes utilizing local materials for construction, reducing the dependence on Earth resupply missions. With the establishment of a base on Mars, the Starship crew embarks on the mission's exploration and research objectives. Equipped with a suite of scientific instruments and research equipment, the crew conducts studies ranging from geology and climatology to the search for signs of past or present life. The exploration is not limited to the vicinity of the base. Rovers and drones extend the reach of the scientists, allowing for the detailed examination of Martian geology, ice deposits, and potentially habitable environments. The research conducted on Mars has profound implications, offering insights into the planet's history, climate, and potential for supporting life. This knowledge not only enriches our understanding of Mars, but also contributes to our broader understanding of planetary science and the conditions necessary for life. The return journey to Earth begins with the meticulous preparation of the SpaceX Starship, ensuring that both the spacecraft and its crew are ready for the interplanetary voyage back home. This preparation involves refueling the Starship using locally produced propellants, a groundbreaking process that involves extracting water from the Martian soil or atmosphere and using it to produce methane and oxygen through electrolysis and the Sabatier reaction. The spacecraft undergoes thorough checks and maintenance, ensuring all systems are operational and the life support systems are fully stocked for the journey. The crew's health and readiness are also assessed, ensuring they are fit for the return trip. The journey back to Earth culminates in the Starship's re-entry into Earth's atmosphere and landing. This phase mirrors the challenges of Martian entry but is complicated by Earth's denser atmosphere and stronger gravity. The spacecraft's heat shield and aerodynamic design play crucial roles in safely navigating this phase, protecting the Starship and its occupants from the intense heat and forces of atmospheric re-entry. The precision landing technology enables the Starship to touch down at a designated site, where recovery teams await to assist the crew and process the spacecraft for future missions. This moment marks not only the successful completion of a round trip to Mars, but also a historic milestone in human space exploration. The reusability of the SpaceX Starship is a key aspect of the mission's success and the sustainability of future interplanetary travel. Following its return to Earth, the spacecraft undergoes refurbishment for its next mission. This process involves inspecting and replacing any worn components, replenishing life support systems, and preparing the Starship for its next journey, whether it be back to Mars or another destination in the solar system. The reusability of the Starship significantly reduces the cost of space exploration, making it feasible to envision a future where Mars colonization and exploration of the solar system are routine. The lessons learned and technologies developed from these missions pave the way for the next generation of space exploration, heralding an era where humanity extends its reach beyond Earth, establishing a multi-planetary presence. One of the most significant challenges of interplanetary travel is the exposure to cosmic radiation and solar flares, which can pose serious risks to the health of the crew. Unlike Earth, with its protective magnetic field and atmosphere, space offers no shelter from these high-energy particles. The SpaceX Starship addresses this challenge through a multifaceted approach to radiation protection. The spacecraft's design incorporates radiation shielding materials that absorb or deflect harmful particles, minimizing the exposure of the crew. These materials are carefully chosen for their effectiveness and practicality, balancing protection with the spacecraft's weight and resource limitations. Additionally, the Starship includes designated radiation shelters within the spacecraft, offering enhanced protection during solar flares or periods of heightened cosmic radiation. Advancements in forecasting and real-time monitoring of space weather also play a crucial role in mitigating radiation risks. By accurately predicting solar flares and cosmic events, the mission can proactively manage the crew's exposure to radiation, scheduling extravehicular activities and sensitive experiments around these forecasts. The prolonged duration of space travel, coupled with the isolation and confinement aboard the spacecraft, can have profound psychological and physiological effects on passengers. To address these challenges, SpaceX incorporates a comprehensive support system designed to maintain the physical and mental well-being of the crew. Physiologically, the microgravity environment of space can lead to muscle atrophy, bone density loss, and other health issues. The Starship is equipped with exercise equipment and regimens tailored to counteract these effects, ensuring the crew remains physically healthy throughout the journey. Psychologically, the mission includes provisions for mental health support, including communication with family and professionals on Earth, recreational activities, and private spaces within the spacecraft. The design of the living quarters emphasizes natural light, personal space, and communal areas to foster a sense of community and well-being. The technical complexities of a mission to Mars are immense, ranging from propulsion and life support systems to habitat construction and resource utilization on the Martian surface. SpaceX approaches these technical challenges with a philosophy of continuous improvement, leveraging each mission to refine and enhance the Starship's design and capabilities. One of the key areas of focus is the reliability and efficiency of the propulsion system, including the Raptor engines and the in-orbit refueling process. Ongoing research and development aim to improve these systems, increasing their performance and reducing the risks associated with long-duration space travel. Another critical area is the development of technologies for in-situ resource utilization, ISRU, on Mars, which is vital for producing fuel, water, and oxygen from Martian resources. This not only supports the sustainability of the Martian base, but also reduces the dependence on resupply missions from Earth. The challenges of interplanetary travel are met with a relentless pursuit of innovation and excellence, embodying the spirit of exploration that drives humanity forward. Through careful planning, robust engineering, and a commitment to the health and safety of the crew, SpaceX aims to overcome these hurdles, paving the way for a future where Mars is not just a destination, but a new home for humanity. One of the most significant challenges of interplanetary travel is the exposure to cosmic and solar radiation, which can pose serious health risks to astronauts. The absence of Earth's protective magnetosphere and atmosphere in space allows for higher levels of radiation to reach the crew aboard the spacecraft. To mitigate these risks, SpaceX has incorporated several strategies into the Starship's design and operation plan. The spacecraft's structure includes radiation shielding materials that reduce the amount of radiation penetrating the living and working areas. These materials are carefully selected to balance protection with weight constraints, as heavier shields could impact the spacecraft's efficiency and payload capacity. Additionally, SpaceX is exploring the use of water storage around habitable areas as a means to absorb radiation, leveraging the spacecraft's existing resources. In the event of solar particle events or solar flares, which can dramatically increase radiation levels, the Starship is designed to include a protected area or storm shelter, where the crew can seek refuge with enhanced shielding until the event subsides. Long-duration space missions can have significant psychological and physiological impacts on astronauts, including muscle atrophy, bone density loss, and mental health challenges such as isolation and confinement stress. SpaceX's approach to mitigating these effects includes a comprehensive health and wellness program for the crew. Physiologically, the Starship is equipped with exercise equipment tailored to the microgravity environment, allowing astronauts to maintain muscle tone and bone density. Nutritional planning also plays a crucial role, with meals designed to provide balanced nutrition and support overall health. Psychologically, the design of the spacecraft's interior prioritizes natural light, personal space, and areas for social interaction to combat feelings of isolation. Regular communication with family and mission control on Earth, along with access to entertainment and leisure activities, are also vital for maintaining mental health. The complexity of sending humans to Mars and returning them safely to Earth presents numerous technical challenges, from ensuring the reliability of life support systems to perfecting the precision landing techniques required on Mars's surface. SpaceX adopts a philosophy of continuous improvement, leveraging data from each mission to refine the Starship's design and operations. One area of focus is the enhancement of the spacecraft's systems for redundancy, ensuring that backup systems can take over in the event of a failure. Another area is the advancement of propulsion technologies to reduce transit times and mitigate the risks associated with prolonged space travel. SpaceX's iterative testing program allows for the identification and resolution of technical challenges in a controlled environment, ensuring that each version of the Starship is safer, more reliable, and more efficient than the last. SpaceX's vision for the Starship extends beyond technological achievements, aiming to make space travel more economically viable. The reusability of the Starship is a cornerstone of this vision, drastically reducing the costs associated with space exploration. By recovering and refurbishing the spacecraft and booster for multiple missions, SpaceX can spread the development and manufacturing costs over many flights, lowering the price per mission. Moreover, the use of in-situ resource utilization, ISRU, for fuel production on Mars further reduces the need for costly transportation of fuel from Earth, making missions more self-sufficient and cost-effective. The Starship program opens up several potential revenue streams for SpaceX, beyond government contracts and scientific research missions. These include commercial satellite deployments, space tourism, and even point-to-point travel on Earth, offering unprecedented transit times between distant cities. The development of a lunar base and participation in Mars colonization efforts also present long-term revenue opportunities through partnerships with governments, private companies, and international space agencies. The scale and complexity of interplanetary travel necessitate collaborations and partnerships between SpaceX, government space agencies, private entities, and international organizations. These partnerships can provide additional funding, share the risks associated with space exploration, and pool the global expertise required to overcome the challenges of sending humans to Mars. SpaceX's collaboration with NASA on the Artemis program, aiming to return humans to the Moon, serves as a model for future cooperation on Mars exploration missions. These partnerships not only accelerate the pace of space exploration, but also ensure that the benefits and opportunities it presents are shared globally. One of the most significant challenges of interplanetary travel is protecting astronauts from cosmic radiation and solar flares. The SpaceX Starship incorporates several mitigation strategies, including shielding with materials that absorb or deflect radiation, like polyethylene or water-rich materials. Additionally, the spacecraft may include a dedicated shelter, a heavily shielded area where astronauts can retreat during solar storms or periods of increased cosmic radiation. Long-duration spaceflight poses psychological and physiological challenges, from muscle atrophy and bone density loss to isolation and crew dynamics. SpaceX is addressing these through comprehensive health monitoring, exercise regimes, and habitat designs that promote social interaction and privacy. The use of virtual reality and connectivity with family and friends on Earth are also considered to mitigate feelings of isolation and confinement. Technical challenges, including propulsion efficiency, life support system reliability, and habitat sustainability, are inherent in the mission. SpaceX adopts an iterative development process, continuously testing and improving the Starship's design based on flight data and simulations. This approach allows for the rapid identification and correction of issues, enhancing the spacecraft's performance and safety over time. The reusability of the Starship significantly reduces the cost of space travel, making missions to Mars and other destinations more economically viable. By recovering and refurbishing the Starship and Super Heavy booster, SpaceX can spread the initial manufacturing costs over multiple flights, lowering the cost per mission. Beyond government contracts for space exploration, SpaceX can generate revenue through satellite deployments, space tourism, and providing logistics for the establishment of space habitats and colonies. The Starship's capacity to transport large numbers of passengers and cargo opens new markets in space, including commercial research laboratories and off-world manufacturing. SpaceX collaborates with NASA, other space agencies, and private entities, pooling resources and expertise to tackle the challenges of space exploration. These partnerships can provide funding, technology sharing, and a framework for legal and regulatory issues, benefiting all parties involved and advancing humanity's presence in space. While Mars is a primary target, the Starship's design facilitates missions beyond, including the Moon, asteroids, and even the outer planets. The ability to refuel in orbit and on other celestial bodies opens the entire solar system to exploration, setting the stage for a new era of scientific discovery and human expansion. SpaceX's philosophy of rapid innovation ensures the Starship will evolve, incorporating advances in propulsion, materials science, and life support systems. These improvements will enhance safety, efficiency, and comfort, making space travel more accessible and sustainable. The success of the Starship and missions to Mars will likely spur increased investment from both public and private sectors, catalyzing a new space race. This involvement will accelerate technological advancements, foster new industries, and expand human presence in the solar system, making the dream of a multi-planetary civilization a reality. One of the most daunting challenges of interplanetary travel is protecting astronauts from cosmic radiation and solar flares. The SpaceX Starship addresses this with advanced shielding materials and design strategies, incorporating radiation-absorbent layers and water tanks strategically placed to shield living quarters. Additionally, real-time monitoring of solar activity allows for prompt protective measures, ensuring the safety and health of the crew throughout their journey. The psychological and physiological well-being of passengers on long-duration spaceflights is a paramount concern. SpaceX incorporates comprehensive life support systems, including exercise equipment and virtual reality environments, to mitigate the effects of microgravity on the human body and reduce feelings of isolation. Ongoing research and development in space medicine and psychology inform adaptive strategies to support mental health and physical well-being. The Starship program continuously faces and addresses technical challenges, ranging from engine reliability to heat shield performance. Space's iterative design process allows for rapid prototyping, testing, and refinement of systems, ensuring that each mission builds on the lessons learned from previous ones. This approach not only improves safety and reliability, but also drives innovation in spacecraft design and operation. The reusability of the SpaceX Starship revolutionizes the economics of space travel, significantly reducing costs and making missions to Mars and beyond more financially viable. This approach, combined with advancements in propulsion and materials technology, paves the way for a new era of accessible space exploration. SpaceX has identified several potential revenue streams to support its interplanetary ambitions, including satellite deployments, space tourism, and contracts with NASA and other international space agencies. Additionally, the development of in-space manufacturing and asteroid mining presents long-term opportunities for economic expansion. Collaborations and partnerships with governments, private entities, and international organizations are crucial for the success of the Mars colonization effort. These alliances facilitate knowledge sharing, reduce costs through shared investments, and ensure that the benefits of space exploration are widely distributed. While Mars is a primary focus, the Starship's design enables missions to other destinations in the solar system, including the Moon, asteroids, and even the outer planets. This versatility opens up new frontiers for exploration, scientific research, and potential colonization. The Starship program is characterized by its commitment to continuous improvement. Future iterations of the spacecraft will incorporate advances in propulsion, life support, and material science, enhancing safety, efficiency, and comfort for long-duration missions. The success of the SpaceX Starship heralds a new era of space exploration, driven by a combination of public and private initiatives. This collaborative model encourages innovation, reduces costs, and ensures that the benefits of space exploration are shared across humanity. The SpaceX Starship represents a pivotal moment in human space exploration, offering a viable path to Mars and beyond. Its innovative design, focus on reusability, and vision for a multi-planetary future epitomize the spirit of exploration and ingenuity that drives humanity forward. The Starship's impact on the future of space exploration cannot be overstated. It lays the groundwork for sustainable human presence on Mars, advances our understanding of the cosmos, and opens up new possibilities for scientific discovery, economic expansion, and cultural enrichment. The prospect of the SpaceX Starship's journey to Mars ignites excitement and anticipation across the globe. This mission represents not just a technical achievement, but a collective leap into the unknown, promising to inspire generations to come and reminding us of the boundless potential of human ambition and cooperation.